Hello class. In today's lesson, I'm going to review some alkane and cycloalkane nomenclature, and I will review the different kinds of butyl groups that we'll encounter, along with the isopropyl group. So in my last video lesson, when I went over the rules for alkane nomenclature, I mentioned the four types of butyl groups you'll see. There's N-butyl, which is just a regular butyl group sticking off of your parent chain. The isobutyl group is pictured right next to it. This still has 4 carbons, but the substituents branch off of that first carbon that's attached to the parent chain. We also have secondary butyl, which looks like a regular butyl group, but it's attached at the second carbon on that butyl group. And then we have a tertiary butyl group where it's still 1, 2, 3, 4 carbons, but we're attached to 1 carbon, and the 3 remaining carbons are branching off of that carbon. We also have the isopropyl group, which is very similar to isobutyl, except it's 3 carbons, and we're attached at the second carbon. One of the assignments I will have my students work on is just practice identifying these different groups given a bunch of compounds. So you'll see some of these things in action before we have to go and name entire compounds. So first, some review. I just wanted to go over an example where we name a regular alkane and try and determine all the substituents. And then I wanted to work in some examples with cycloalkanes. So our first step, we need to find the parent chain, which is the longest consecutive chain of atoms. When I start here, I see 1, 2, 3, 4, 5, 6, 7 as one possibility. If I start on the right side, 1, 2, 3, 4, 5, 6, 7 is my other possibility. Since I have 2 possible parent chains that are 7 carbons long, I need to remember the rule that says the more substituents, the better. So the parent chain that will have more substituents sticking off of it is better. So this one that I started in purple ends up with 1, 2, 3, 4 substituents, and that would be the better parent chain. So my parent chain here is going to be this one. Now I have to number my carbons, and I need to number in such a way so that my substituents have the lowest possible numbers. I number from the top, 1, 2, 3, 4, 5, 6, 7. My substituents end up with the numbers 2, 3, 4, and 5. If I were to number in the other direction, my first substituent would end up on 3. So I know that this is the better method to number in because my first substituent ends up on 2. So then I just need to identify my substituents. I have a methyl group on 5, that is 1 carbon. I have a methyl group on 2 and a methyl group on 3. I also have 1, 2, 3, a propyl group on 4. So I know I need to alphabetize between methyl and propyl. Methyl will come before propyl because M comes before P. So I have 2, 3, 5, and then I need to use a prefix to combine all of my methyl groups. Since there are 3 methyl groups, it becomes trimethyl. Then I put my number for my propyl group. For propyl, oops. And then my parent chain. So my parent chain was 7 carbons long. This is heptane. And that is the complete name for compound A that we see here. All right. In my next one, I have a cycloalkane. That means I have a ring. First thing I want to do is figure out what my ring is. This ring has 6 carbons in it. So I know I'm going to be looking at cyclohexane. Okay. And then when I go to number, I want to number in a way so that I have the lowest numbers possible for all of my substituents. The nice thing about this is I can either number this way, 1, 2, 3, 4, 5, 6, or I could start down here and go 1, 2, 3, 4, 5, 6. Either method works because this is a symmetrical cycloalkane. So I'm going to stick with this method up top. Now on carbons 1, 2, 4, and 5, I have a methyl group. And on carbon 3, I have a propyl group. So again, same process as we did in letter A. I'm going to combine 1, 2, 4, and 5 for my methyl group. Since there's 4 of them, I'm going to use the prefix tetra. And then on the third carbon is propyl. Cyclohexane is my parent chain. That would be the complete name for the compound in letter B. Now, when we're talking about cycloalkanes, it can be a little more challenging than that, especially if we start seeing some different kinds of groups attached to our parent chain. There are also times where you'll have a cycloalkane or a ring in your compound, and it won't be the parent chain. So we'll talk about some examples like that too. In this first one, I see cyclohexane again, but I need to figure out my numbering system. I have a methyl, an ethyl, and a propyl group in this first one that I'm looking at here. So I want the lowest numbers possible. If I start here, I go 1, 2, 3, 4 as an option. If I started with the methyl group, 1, 2, 3, 4, 5. So that's not an option. The other possible option is if I started with the ethyl group, 1, 2, 3, 4. So I've got 1, 3, 4 as an option versus 1, 2, 4 as an option. I want to go with 1, 2, 4. That's the better numbering system. So I'll go with the one that I had here. 1, 2, 3, 4, 5, 6. So then I just need to alphabetize each of my groups. E comes before both M and P. So I have 4 ethyl. Then M comes before P, 2 methyl. And then my last one is 1 propyl. Cyclohexane. All right, on to the next one. This next one, I see a 5-carbon ring that is cyclopentane. And I've got 2 substituents. And this is interesting because I could number 1, 2, 3, or I could number the other way, 1, 2, 3. So now it looks like I have a tie between 1, 3, and 1, 3. So then we have to look at alphabetization. The 1 is going to go to the group that comes first in the alphabet. So we first need to identify each of our groups here. So my first group at the bottom is a methyl group. That's an M. This group here, it's one of my famed butyl groups that we talked about. This one is isobutyl. So with isobutyl, the iso prefix does count in our alphabetization. So we have an I. I comes before M. I should number with a 1 for my isobutyl and a 3 for my methyl group. So this is 1 isobutyl, 3 methyl, cyclopentane. All right. Again, getting used to identifying those prefixes is really, really important. and especially with the butyl groups. I guess I should go back and remind you that iso counts for alphabetization. So isopropyl and isobutyl, we would use the I for alphabetization. But for sec and tertiary butyl, we have to use the B. So you go with the B for alphabetization. Just keep that in mind. Okay. And then my last one that I'm going to name, and then we're going to draw a couple. I see that I've got cyclobutane, that is 4 carbons, and a 1, 2, 3, 4, 5 carbon chain. This is tricky because you have to figure out what's the better parent here. Typically, cyclobutane would be considered the parent chain, but our branch sticking off is actually a longer carbon chain than the cycloalkane itself. So since I've got 5 carbons in my chain over the 4 carbons in the ring, pentane is going to be the parent chain, and we're going to have to make cyclobutane a substituent. So just like we do with other substituents, the ane becomes an ill ending. So cyclobutane comes cyclobutyl. And then I just need my number. So I am on the very first carbon of my pentane chain. So it's 1 cyclobutyl pentane. All right. So do pay attention to the longest chain possible when you've got alkanes, because sometimes the alkane is going to be the parent and sometimes the cycloalkane is going to be the parent. All right, last thing, I just wanted to draw a couple of these so that way we get some practice in. So first thing is, remember that cyclo prefix. If you see that cyclo prefix, that means we're dealing with a ring. So we've got heptane, which is 7. This is a 7 carbon ring. All right, so the way I draw cycloheptane, I start with the bottom, I go up on both, and then I add one more up top. So then you'll see I've got 1, 2, 3, 4, 5, 6, 7 carbons there. It's tricky. All right, and then it doesn't matter where I start with my numbering. Tetra tells me I have 4 of my methyl group, so I've got 4 methyls sticking off. And so you can pick wherever position you want as your number 1 position. 1, 2, 3, 4. That would be 1, 2, 3, 4 tetramethyl cycloheptane. All right, on my next one, I see cyclopropyl with that YL ending, meaning that's a substituent. So this is going to be an interesting one. I'm going to start with octane. 1, 2, 3, 4, 5, 6, 7, 8 carbons. And on carbon number 1, I'm going to draw a branch down and draw my cyclopropane, which is just a triangle. Keep in mind, I got to make some sharper corners here, but keep in mind this is my first carbon. So second, third, fourth carbon's a methyl group. And on the 5th carbon is tertiary butyl. It's like the chicken foot. And this would be 5 tertiary butyl, 1 cyclopropyl, 4 methyl octane. Okay, that is all for our practice examples for today. The next lesson will move into nomenclature for alkenes and alkynes, things that have double bonds and triple bonds.